Hello, friends. This is Jim with Science Talk, and we'll explain what this little critter is all about here in a bit. I have a really cool story here. Um, this is about a dinosaur, a new species of dinosaur that was found in the Italian Alps, and it's survived being blown up, from World War II activities or being damaged by excavation activities. So what do we have here? We have a significantly good-sized meat-eating, carnivorous, four-fingered dinosaur from the Italian Alps, as I mentioned earlier. And if you look at this illustration here, it's shortened, but there is the fourth finger. You got 1, 2, 3, and there is a shortened fourth finger that you can see there. So this new find has been given for now, the scientific name of Saltrio venator zanelli. It lived about 200 million years ago. So this puts it right in the Jurassic. The first known Jurassic dinosaur specimen found in Italy. It's also the oldest known ceratosaurian, as well as the largest. It weighed about a ton. Now, these are well-known predatory dinosaurs, and this is 200 million years ago. It's probably from the earliest part of the Jurassic. So you think about it. Okay, back then, these animals lived in kind of swampy areas or low-lying areas, very hot, very humid, and they died, fell in the ground, most likely into some sort of shallow water. Marine creatures, organisms chewed on it, dined on it, and then it finally got buried. And then as the Alps began to form, it was lifted upwards. And the Alps formed about 30 million years ago. So the Alps are a recent mountain chain. So this is a quote from the lead researcher, Cristiano Dal Sasso, Cristiano Dal Sasso, who's a curator of vertebrate paleontology at the Milan Natural History Museum. This is his statement. It is a miracle that has survived such a long chain of events, drifting away to the sea, floating, sinking, being scavenged by marine animals, reworked by sea bottom currents, buried, uplifted within a mountain chain, and eventually blown up by human explosives. And the reference there was that previous industrial workers had used dynamite to blow up the quarry, which broke the fossils into hundreds of pieces. So now they had even more of a jigsaw puzzle to put back together. So Angela Zanella, an amateur fossil hunter, discovered the bones in 1996 in a marble quarry near Saltrio. So now you can see the scientific name is Saltrio venator, and then Zanelli. Zanelli is an homage to Mr. Angelo Zanella, who founded the specimen. And by the way, in Latin, venator means hunter. So Saltrio is reference to the town, and venator means hunter. And then Zanelli, the species name, is in reference to Mr. Zanella, who found the specimen. Now, Saltrio is about 50 miles, 80 kilometers northeast of Milan. So Dal Sasso and his colleagues started work in the area. They dug up more bones. They then had, the bones had feeding marks on them, indicating grazing, some sort of eating activity being done by marine invertebrates. And these chew marks makes the specimen one of the few dinosaur specimens showing signs of marine invertebrate scavenging. There are indications, there are fossils that show bite marks from other predatory dinosaurs, so indicating that such a behavior in the predators as well. The other specimen that showed marine invertebrate scavenging was one of an armored ankylosaur, Aletopelta, and the remains of a Letopelta were likely nibbled on by, again, scavenging marine invertebrates, lived off the coast of what's now southern Cal. And that report on a Letopelta was found in a study going back to the 1996 Journal of Paleontology. But what makes this find really interesting is that, yes, the bones are fragmented, but there's enough evidence to indicate that this dinosaur had 4 digits, 4 fingers. The oldest dinosaurs, such as Carnivorous, had 5 fingers, but all known ceratosaurs, including the newfound Saltriovenator, Limosaurus, Ceratosaurus, Eobellosaurus, had 4 fingers. This is the oldest. So somewhere in the evolutionary line to Ceratosaurus, the 5th, or the outermost digit, right? 1, 2, 3, 4, 5. Thumb is considered the first digit. The outermost digit, okay, was lost, right? Almost a pinky to you and I, resulting in the 4-fingered hand of Ceratosaurus. So this is an explanation by Matthew Lamana, who is an assistant curator of vertebrate paleontology at Carnegie Museum of Natural History in Pittsburgh. He happened to not be involved with this current study. Later theropods, which are your carnivorous bipedal dinosaurs, such as Tyrannosaurus rex, Velociraptor, right? They went further, losing the 4th or ring finger, leading to the 3-fingered hands that we see in Allosaurus, Oviraptor, and so forth. Now, remember, T-Rex kind of had 2 fingers, first and second. That's it. So they even went further. Now, most of the other theropods that had the 3 fingers, the Oviraptor, the Velociraptor, Allosaurus, those 3 fingers gave rise to the bird wing. In fact, the middle finger is pretty much the digit that supports most of the wing. You see similar things with pterosaurs and pterodactyls and the flying reptiles. Now, there was some debate over which finger these 3-fingered theropods lost, but Saltriovenator helps to show that the 3-fingered hand of these theropods was produced through loss of the 4th finger rather than the 1st, or the thumb. Now, I'm going to come back to this idea of the digits and so on. Let me first give you the rest of the information about Saltriovenator zanella. It was large, about 26 feet, 8 meters in length. Okay. Co-researcher Simone Maganuco, who's a vertebrate paleontologist at the Milan Natural History Museum, basically stated the size of this animal. Goes on to say the revolutionary quote-unquote arms race between the stockier predatory and giant herbivorous dinosaurs involving progressively larger species had already begun 200 millions of years ago, beginning of the Jurassic. 3 of the Saltriovenator zanella's 4 fingers had powerful claws, which is, served as a quote-unquote terrible weapon of war during the dinosaur age. And this is a statement by Professor Dal Sasso. So where this report was, it can be found, it was published online in the online journal Pearl, or Pearl, P-E-E-R-L. Now, so this is a really cool find. So we see some tendencies from 5 to 4 to 3 digits. Now, if we look at this, this is an artist rendition, and as you can see, here are the 3 powerful claws, and there's the 4th one there. The artist is presenting this as having some sort of a feathery covering on the skin. You can see respectable teeth here. I certainly would not want to be on the receiving end of that thing. As an eye, if you look at the way the eye is, and this is based on the skull, so on, and looking at the orbit, it's obviously shown that the eye is looking more situated forward. So you look that on the other side, combine that together, and you get a bit of stereoscopic vision. Most animals that have eyes on the side of the head, they look out this way, but there's a blind spot right in front of the snout, and And such animals, which are typically ungulates, which are grazing or foraging organisms, typically do not have stereoscopic vision. Stereoscopic vision helps you judge distance to where you wish to go, the intended target, so forth. Now, it is probably an unknown fact that in the beginning of vertebrate evolution, the five-fingered or five-digit form was not always the case. Stephen Jay Gould wrote probably one of my favorite essays he ever wrote, and I have read basically everything the guy wrote. He wrote this essay, and it's actually the title of a book called 8 Little Piggies. A little kind of a play on the, this piggy went to market, that little nursery rhyme thing. And in this essay, he describes how specimens have been found where the organism had 8 digits. Others had 7. But several specimens have been found, different species, where the organisms had 8 digits. And these are, we're going back into, the Paleozoic back then, into the Ordovician, Silurian, back then. And we're looking at pretty much marine forms. But when you look at the bones that make up, say, fins or paddles, flippers, what have you, we can clearly see that there are phalangeal bones making up 8 digits. And of course, over evolutionary time, it got reduced down to pretty much, 5 or 4 digits, and in some cases being reduced further down to 3 or fewer, with either the remaining bones being splints or having totally disappeared. For example, if you look at horses, if you look at the evolution of the horses, we can see at one point they had 3 toes on the ground. And over time, with the intermediary forms, we see the outer 2 toes, which would equate to the second and fourth fingers, basically shortening in length. They're still visible, but they're not reaching the ground until they finally disappear. So what we're left with when a horse stands on his or her hooves, they're literally standing on their middle finger. So imagine us standing and walking on our middle fingers. That's what they're doing. If you look at rhinoceros, they're also what's called an odd-toed ungulate. Horses, tapirs, rhinoceri are odd-toed ungulates, meaning they have an odd number of toes. And it's a suborder Perissodactyl of the ungulate order. And the rhinos and the tapirs have 3 digits on the ground. Most ungulates are of the suborder Artiodactyl, which are even-toed ungulates. So cows, goats, sheep, rams, just about all the ungulates we see around worldwide, they have 2 toes, 2 hooves on the ground, and basically it's the 3rd and 4th digits that are touching the ground. So it said the idea has always been 5 digits or fewer is not true. Actually, at one point there was up to at least 8, or that's what we have evidence for, 8 digits that vertebrates had, and over time it got reduced down. This is not the only situation where we see a reduction in structures. If you were to look at, say, a lamprey or a hagfish, okay, they are members of the phylum Chordata. They're subphylum Cephalochordates. Okay. Vertebrates are a subphylum of Chordata. The features that define chordates are a notochord at some point in their development, a dorsal hollow spinal nerve tract or nerve cord, and the presence of pharyngeal gill slits, again, at some point in their development. All vertebrates start out with a notochord that gets replaced by bony structures during embryonic development. That includes us. All vertebrates have at some point in their development, whether it's retained or not, but they have at some point in the development pharyngeal gill slits, including us. And we all end up with a dorsal hollow nerve cord. Invertebrates have a ventral nerve cord. The hollow references the fact that it's found within a cavity, i.e., if you look at the what's called the spinal foramen, if you take a vertebra, right, you see the main body there, and there's a hole right above it. That's what the spinal cord is. Okay, it's usually called the spinal foramen. Foramen means hole. So going back to my other example, if you look at the lampreys and the hagfish, and you count the number of gill slits on the side of their head, there are 7 of them. If you look at a lot of sharks, a lot, not all of them, they have 5 gill slits. There's a 6-gilled species of shark, and there's a 7-gill species of shark. Those are evolutionary side shoots. If you look at the number of gill arches in a bony fish, there are 5 of them. It's just that instead of having separate slits for each one, all the gills are covered by a bony plate called the operculum. So what happened to those other 2 gill arches? They became our upper and lower jaws. Gill arch 1, gill arch 2. Your upper jaw is the first gill arch, your lower jaw is the second gill arch. They modified into jaws. Remember, lampreys and hagfish are jawless fish. They just have a big old raspy sucker at the front of their heads. They don't have jaws. The first 2 gill arches in vertebrates modified to become the upper and lower jaws. Just again, showing an interesting trends in evolution. So we see the reduction from 8 digits down to 2 or 1. Okay. 5, 4, and 3 are common. We see the reduction of 7 gill arches down to 5, with the first 2 becoming your upper and lower jaws. So anyway, this is a really cool find of this dinosaur specimen with 4 fingers. Pretty big, pretty decent sized predator, certainly larger than a velociraptor. And another specimen to help fill in our understanding of evolutionary processes and relationships. So I hope you found this interesting, and we'll talk soon. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it, based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. and I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. We need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So together we can get this information to more and more people. Thank you. Thank you for your support.